Okay, thank you so much. My name is Johnny Vega. I am a full-time professor in the University of Medellin. I am a civil engineer and master in geomatics, and I am a PhD student in the program of doctorate in engineering in the University of Medellin. I would like to talk with you. This is a brief summary of these two papers. A little bit of context. The study area is in Colombia, in the northwestern corner of South America, a country very susceptible to geodynamics processes by the convergence of several tectonic plates and the influence of the intertropical convergence zones with heavy rainfall patterns. Medellin is the center of the metropolitan area called Valle de Aburrá, and the risk analysis area is the northeastern zone of the city, where 35% of building damage and 74% of death by natural phenomena are landslide related. And this zone is characterized by informal construction or building of low-income neighborhoods without urban planning and seismic provisions. Is one of the purest area of the city. This is a panoramic view of the study area and an aerial view of the study area. In this area, almost 59% of the buildings are with unreinforced masonry. This is a particular zone with geomorphological condition of deposits of residual soils, several streams, a presence of local faults. In this slide, you can see the typical structures of the buildings. This is the workflow for landline hazard assessment. This is a probabilistic approach that takes into account uncertainty modeling of geotechnical soil parameters and the uncertainty of the soil saturation because of rainfall. We use two conditions, static conditions related to the factor of safety and probability of failure, and a dynamic condition using the critical acceleration considered in the PGA map. The result of this stage of the research is to obtain the annual probability of failures that you can see in this image. This is the workflow for physical vulnerability. For this stage of the research, we used the cadastral map and cadastral database. 5 building characteristics that were used: age, condition, number of stories, type of structural type, and the type of roof. And then the building were classified according to the HASUS classification using or simulate. We use to simulate 4 structural scenarios. Scenario number 1 was the original structure, material, and type. Scenario 2 consider all buildings in the zone built with masonry. The scenario 3 consider any structural type of a structure with a stiffness element, and the last structural scenario was the structural type with supporting walls with a stiffness element that fulfill the requirement of Colombian building codes. With this information, we generate vulnerability decision trees, and the final product of this stage was the physical vulnerability map. In this slide, you can see the quantitative risk assessment. And in this stage of the research, we use the results of the previous stage, like a hazard, total probability of failure, and physical vulnerability index. And the economic losses for the building damage was carried out using a statistical method, specifically bootstrapping method. With this method, we can obtain different risk scenarios, and we can obtain different risk maps of the study zone. Which is the purpose for this risk map? Urban planning guidelines and urban planning strategies for reduction of the risks in the pure building and the pure neighborhood of the city. The implementation of the aforementioned workflows was thinking in different stages. The stage 1, 6 years ago, was implemented in ArcGIS, Python, and model builder environment. The stage 2 of the implementation was developed in 2017 using Visual Studio, MapWinGIS, and Python. And the last year we did a last version of the software in completely open free source using QGIS and GDAL and Qt interfaces. The case study, more than 48,000 buildings in the communes 1, commune 2, and commune 3 in the northeastern zone of Medellin. And you can see the structural material maps of these communes. We simulate the hazard and vulnerability for different values of horizontal ground acceleration, as you can see in this table, and we obtain the probable maximum economic loss for cells with a damage index higher than 50%. And also we estimate the potential loss in relation to vulnerability index for areas with pneumatic displacement higher than 5 centimeters. In this slide, you can see the risk maps, considering the magnitude of an earthquake according to the Colombian Building Code. And you can see in this part of the slide different simulations of according to the different scenarios that were considered. The line in blue color is the scenario with the original structure, material, and type, and the purple line is an assumed hypothetic scenario where structural types is supporting walls with a stiffness element that fulfills the requirement of Colombian Building Code. In this slide, you can see how the structural intervention of the building can produce a reduction by almost 21% in the total land risk. Hence, a structural modification in building is convenient to decrease the risk level at informal settlement in urban planning process. And it is noted that the improvement of the structural quality of building has a major effect on estimated damage costs. Even without the full implementation of the Colombian Building Codes from 2010, this cost may decrease between 0.5 million and $22 million depending on the period of earthquake recurrence, according to horizontal ground acceleration. This is an example for a simulation that we made in 2016 in the Commune 3 Manrique. And then in 2017 occurred a landslide in this zone of within the cycle. The hazard was moderate, and the vulnerability was high. If you combine the moderate or medium hazard with high vulnerability, you obtain a high risk level. And this is an example for the use of our methodology. And what about the conclusions? The economic losses in the study area caused by landslide induced by earthquake and rainfall are significant for ground acceleration higher than 0.3 Gs. In the case of lower acceleration, the affected areas are those with steeper slopes with pure quality housing construction, mostly wooden buildings. The proposed methodology can be used to obtain an estimate of the probable economic losses by earthquake and rainfall-induced landslides, taking into account the uncertainties of the building codes in the study zone. The methodology is a cost-effective approach and provides a basis for decision-making stage of urban planning process or urban planning strategies, and the prioritization of areas requiring further studies using data obtained from secondary sources. And this methodology allows different seismic and structural scenarios to be evaluated with the aim to define the most appropriate risk management strategies. The amount of investment required to reduce the risk of exposed buildings to an acceptable level of safety can be carried out through cost analysis following this methodology, and the proposed methodology may be transferable to areas with similar types of structure or similar structural systems. And thanks for your attention. This is the link for my research gauge profile. If you need to write me or mail me, do not hesitate to do it. And thanks.